Hi everyone, welcome to another video. Today we'll be solving the question of LRU cache, where we have to design a data structure that follows the constraint of a least recently used cache. So here we have to implement this LRU cache class, and we have to implement these get and put functions where we have key value pairs. So initially let's assume we are storing our key value pair somewhere. So let's say we have a class node and we have integer key and integer value, and we are simply storing it initially. And let's assume initially we have three keys. Let's call it key 1, 2 and 3 in our cache, and they are stored in an array. So here we can assume we have an array of nodes, and let me draw an array initially, and we are adding to this array at index 0. When we are adding a new node to the array, the node at index 0, it's the most recently used one, and the node at the end of the array, it's the least recently used one. And let's say the capacity is 3. That is why I have indexes from 0 to 2. So this array is sorted based on the timestamps, and we have to implement our get and put functions such that when we do a get on a particular key, so that key, it's going to become the most recently used one, and we have to reorder our array. And when we do a put call, so we can update an existing value for a key, or we can insert a new key value pair. Whenever we are doing get and put operations, these operations are going to make that key as most recently used, and we have to remove that key from our data structure and move it to the front of the array. So in case of an array, if we simply use an array, then the problem is it's going to take O of n time in reordering elements. And let's say if we have a single linked list in place of an array, then also it's going to be O of n time in reordering elements, and we have to implement our get and put operations in O of 1 time. We need to implement our get and put operations in constant time complexity. So to do that, what we can do is we can store our key value pairs in a doubly linked list. So what doubly linked list is going to help with is whenever we want to reorder a node and make it most recently used, we can simply remove that node. So let's say we do a get operation for key 2. So here in the nodes, I'm just writing the keys. These nodes also have the values. So if I do a get operation for my key 2, so first I need to get the reference to the node with this key 2 and value, whatever the value is. So to get that in O of 1 time, what we can do is we can map these keys to their respective nodes in a hash map. So once we have that reference, what we can do is we can update the previous reference, the next pointer of previous reference, to point to 2.next. And what we can do is 3.previous, it's going to point to node 1, and this 2.previous, it's going to be null, and 2.next, it's going to be null. And this operation is going to remove the node 2 from this doubly linked list. And once we remove it, we can add this node 2 at the front of our doubly linked list and adjust the pointers accordingly. And once we have done that, we would have reordered our cache and we would be done. So this is our simple get operation. And in case the key does not exist in our cache, we can simply return -1. So for our get operation, what we did, we first did a remove call, and then we did an add call. So we can discuss what these two calls do. So the get operation, it's simply going to reorder the nodes, and we don't need to check the capacity of our cache. Now what happens if we do a put operation? So let me redraw our doubly linked list with capacity as 3. And here I can create a head node, and here I have a tail. Now let's say we want to add a new key value pair. So the key is 4 and value can be anything, let's say 7. So now what is going to happen, we have to remove this least recently used element and add this key at the front of the cache. So here we can simply do our add operation first, and then we can check if the capacity exceeds the given capacity, and then we can do a remove operation. And if we are updating the value of existing key, so let's say if we just update the value of existing key to, let's say 10, then we need to simply reorder this node 2 and move it to the front of our cache, because this node 2, this would become most recently used key now, and we simply reorder our nodes. when we are updating the value of an existing key in the cache. And for this, we can simply have an if else check. So if the key that we are doing a put operation for, if it exists in our hash map, then we can simply update its value and move the node around. And if it does not exist in our map, then that means it does not exist in the cache. Then we can simply add it in the front of our cache and evict the least recently used node if it exceeds the capacity. And if our newly added key, if it does not exceed the capacity, then we can simply add it to the front of our cache. And that's our put operation. One thing we have to be careful about when dealing with our doubly linked list and our map is that these two should be in sync with each other, as they both are storing the data about our cache. If we are adding a new key value pair node to our doubly linked list, then we have to also add it to our hash map. And if we are removing it from our doubly linked list, we also have to remove it from our hash map. So we have to be sure that these are in sync with each other. For our code implementation, we have to implement this LRU cache class. So before writing the code for LRU cache class, I can start by writing our node class where we are storing the key value pairs. And I can also create next and previous pointers because this is going to be a doubly linked list. And to initialize a node reference, what we can do is I can pass in key and value in the constructor and assign keys and value. So after creating our node class, we can think about writing the LRU cache class. And as discussed, we are going to need a head and a tail for our doubly linked list. So I can create a node head and a node tail. And inside the constructor, I can create a new node and give the key and value as -1 for our head and same for our tail. And I can set head.next as tail and tail.previous as head. And here I am assuming that we are adding new nodes at the head of our doubly linked list. And also we are going to need capacity. We just int capacity, and here I have to set this dot capacity as my capacity. And one more thing I'm going to need is our hash map. So I can create hash map and integer, and it is going to map to the node. And inside of constructor, I can initialize my hash map. And once we have this, we can think about writing our get function. And in our get function, if the key does not exist in our hash map, then we have to return -1, and we can simply return -1 here. And if it does exist in our hash map, I need to first retrieve the key, the node which is being referenced by the key. And once we have the node, what we need to do is we need to remove that node. So the reason we have to remove it from the doubly linked list is because we have to reorder it and add it at the front. And once we have done that, we can simply return node.value and we would be done for our get operation. So first let's try to write remove and get functions. So for my remove function, what we can do is we can pass in the node reference and now update the pointers. So node.next.previous is going to be equal to node.previous, and node.previous.next is going to be equal to node.next, and we can set node.next as null and node.previous as null. So these two operations, these are optional because we don't need because once we do these two operations, we are not going to have the reference to our node, because after this function returns, we are going to lose the reference to our node and it's going to be garbage collected. So these two lines are optional. So now let's write our add function, and again we can pass in the node to add to our doubly linked list. So this node is going to come in between the head and head.next node. So we can store our head.next here, and now I can update the pointers. So my head.next is going to be equal to node, my node.next is going to be equal to next, my node.previous is going to be equal to head, and my next.previous is going to be equal to node. So this is my add function. Now I can remove the comments, and here I can pass in node to my remove function and node to my add functions. So this way we have our get function implemented. For our put function, we are going to need a similar check. So first we can check if map does not contain the key. So if it does not contain the key, then we have to create that node. So if it does not contain the key, then we have to create a new node with these key and value. And once we have this, so what is the next step? So we need to add this to our HashMap as well. So this would be key and node map.put. So next thing we can do is we can simply first add the node to our doubly linked list, and after adding we can check if it exceeds the capacity. So to exceed the capacity, we can simply check if map.size is greater than capacity. If it is greater than capacity, then we have to remove the least recently used node. So the least recently used node here, it's going to be tail.previous, and we can simply remove that. So remove LRU, and we have to also remove it from our HashMap. So map.remove LRU.value. So here we first need to store tail.previous in a node, because if we call remove on tail.previous directly, then it's going to update my tail.previous, and map.remove tail.previous, it's going to give me a wrong value. So that is why I had to first store tail.previous in a separate variable, and this way we will be done. And if it exists in our HashMap, then what we can do is we can first retrieve that node and do map.get key, and now I have to update that key to its new value. So I can do map.put key and value, and before updating the key value, what I can do is, since this key is being referenced, so I can remove that node, and after I update the key value pairs, I can update my node.value as well, node.value equal to value, and now I can add that node to the front of my doubly linked list, and this way this is going to reorder that node correctly. So let's try to run this and see what happens. Okay, this is giving me compile error, so this should be key and node. So here, before updating the HashMap with the node, what I have to do is I have to update my node.value equal to value before updating the HashMap. Now this will correctly update the key to its new node. If I would have done this call before this call, then it would have simply re-added the old node to our HashMap. And here I have to pass in LRU.key instead of LRU.value. And yeah, that looks good. So let's try to run it, and that works, and let's try to submit. And yeah, that looks good as well. So I hope this made sense. It could get a little bit tricky, like working with HashMap and doubly linked lists and keeping both of them in sync. This is a really good question which is going to test your skills and knowledge. So if you have any doubts, let me know in the comments, and I'll see you in the next video where we are going to cover the question of design Twitter, and after that we are going to solve the question of max stack. So I'll see you in the next one.